Hello guys, today we will discuss about decision tree. Okay, what is decision tree? Why we have to use decision tree algorithm? So decision tree is like a normal tree. So it consists of some nodes, which is a root node and leaf nodes. Okay, next branches like that. So we want to build a decision tree by using different algorithms like ID3 algorithm. Okay, by using ID3 or cart hands algorithm, by using different algorithms you can build a decision tree. So decision tree, why we have to use decision tree? Decision tree is used for the classification and regression purpose. So today we will discuss about classification. Okay, and before that, how to build a decision tree? By using ID3 algorithm. Here I am using some article to explain the decision tree, which is a good article. uh, by using this we can easily understand. Okay, first if you observe that this is a decision tree example. So if you observe that age is less than equal to 30, which is a root node, and remaining are the sub branches, okay, sub nodes, and last nodes are the leaf nodes. The leaf nodes does not consist of any other sub nodes. Okay. Coming to the ID3 algorithm. So ID3 stands for iterative Dichotomist algorithm. So Dichotomist is nothing but you have to divide the, nothing but you have to form the um, features into two or more nodes. Okay, I want to build a decision tree. Here, for example, let us consider this COVID data set here. So we are already know that. So in first considering the data set, first you have to identify how many attributes we have and what is the target variable here, and is there any independent features or dependent features in the data set. Okay, first one is target variable. If you observe that infected is the target variable. Okay, so here S and no, so different two types of unique values here. And if you observe that fever, cough and breathing issues, these are the three features. Based on three features we can identify whether the patient is infected by the virus or not. Okay, out of these three attributes, which by using which attribute I have to build a decision tree? Where is the root node here? Okay, for that you have to calculate the information gain and entropy. So entropy is the part of information gain. So you have to calculate the information gain for each and every attribute except the target variable. Okay. Okay, coming to the entropy. What is the formula to calculate the entropy? So if you observe that the formula is clearly mentioned. So entropy equal to sigma of pi into log px. So we can also mention like that, sigma px into log 2 of px. Okay. And coming to the calculate information gain. So information gain formula, how to calculate entropy minus, so based on particular SV of SY into entropy of SY, which is one step. So first, what is the needed steps to build a decision tree by using ID3? You have to calculate the information gain. So by using information gain, you can identify which attribute is the best attribute, and by using Gini index also you can identify. Coming to the information gain, we are considering high information gain value for the attribute. For example, if the attribute having high information gain value, we are considering as the best attribute. But initially we don't know about the information gain of every attribute. So for that you have to calculate it. Okay, so if you observe that in this data set we have 14 records, right? First you have to calculate the entropy for the entire data set. Okay, so if you observe that, so in data set we have 14 records, and coming to the target variable, it consists of S and no unique values. So here how these values are came means, for example, uh, when we have to perform entropy, we are considering positive minus negative, not negative minus positive. Okay, in target variable we have 8 S values out of 14 records, and we have no 6 no values out of 14 records. Okay, if you perform some calculation, you can get 0.98, so which is the entropy for the entire data set based on the target variable, based on the target variable. Okay, then first we have to calculate the information gain for the fever. Okay, for that you have to take only fever attribute, and that too it consists of s or no unique values. First we are taking the s values in the fever attribute. Okay, so based on the this we have to calculate the entropy for the fever. Okay, and we have to divide the data set based on the fever attribute, so it consists of s or no kabatti s and no, then we have to divide it, and after that we have to calculate the entropy for the fever attribute. Okay, so here we have two unique values, so s and no, right? So how many s values we have? 8. And if you observe that we have 8 records which are, this is belongs to s value, so that's why 8. Okay, and here also we have to consider the target variable. So how many s we have in target variable? We have 6x, 6s out of 8 target variables. So you have to follow this formula and calculate the zero entropy. So finally we got 0.81, and similarly you have to calculate the entropy for no value which is based on the target variable. So at that time we got 0.915. Finally how to calculate the entropy. Entropy is done. Okay, information gain value. So information gain value, we are taking the fever attribute. Okay, so the final formula is entropy of s. Remember we are already calculated entropy for the entire data set. Okay, then we are already calculated entropy for s at s value in the fever attribute and no value in the fever attribute. So how much of value we got? 0.81 and 0.91. Okay, so total entropy value for the entire data set is 0.99. So 0.91 minus, so we have to apply this formula. Finally we got 0.13. So information gain value is calculated for one attribute in the data set. Okay, fine. Then you have to follow these steps for the remaining attributes also. So remaining attributes are what are the remaining attributes? Cough and breathing issues. For cough and breathing issues also you have to calculate the information gain. Okay, so if you observe that 0.04 and 0.40 and 0.13, what is the highest information gain value here? 0.40 is the highest value. Okay, fine. So based on that you have to calculate it. So if you observe that, so what is the highest information gain value is 0.40. That's why you are taking 0. Breathing issues is the best attribute out of all the attributes in the target variable in the data set, except the target variable infected. Okay, so if you observe that breathing issues, again how many values we have? Yes or no. Then again you have to calculate the fever attribute. You have to calculate the information gain for the fever value based on the breathing issues. Okay. So how you calculate this? So again you have to take the breathing issues values, cough values and fever values. So again mainly you have to concentrate on the fever and breathing issues and infected. So similarly, we have to calculate the information gain for the remaining attributes, fever and cough attributes. So which attribute having highest information gain value? So you are taking that attribute as the left node for the breathing issues. Okay. So in this way, you have to build the decision tree based on the ID3 algorithm. And if you observe that this is the final yes, so this is the final decision tree. Okay, uh, thank you for watching.